Welcome back to our numerical analysis series. In the previous video, we talked about Gauss elimination method, and in today's video, we want to continue with Gauss Jordan elimination. Of course, Gauss Jordan elimination is an improved version of Gauss elimination. So the question is, where to use So we have used Gauss Jordan elimination to solve the system of linear equations. So let's have the question down that we are expected to solve using Gauss Jordan elimination, which is an improved version of Gauss elimination method. So here we go, we have these three systems of linear equations and we are to solve them using our Gauss Jordan elimination method. The first thing that we need to do, like we did earlier on in our Gauss elimination, is to write this as a system, as an augmented matrix. So we need to write it in the form of augmented matrix. And here we know we have got 4, -2, 3. So having write this as an augmented matrix in Gauss Jordan elimination, it is a bit different from Gauss elimination because in Gauss elimination we are interested in making the second row and the third one with its corresponding columns, zeros, but we have more operation to do in terms of Gauss Jordan elimination, and to enable us to do this we might need to interchange row, or what we revise the equation. So we need to revise equation 1 and equation 2, or interchange the row 1 and row 2 in order to get better organized matrix. So the first row operation is switching. We need to switch. This operation is when you switch or swap the location of two rows in this matrix. We can switch the first and the second rows, so that the first one moves to the top, the second one moves to the top, and the first one comes down. So the goal of this switching is nothing but to get a better organized matrix. So if we switch the first one and the second one, we will simply have 2 here. This will be 2. We will have 2. Then we will have 5, and then we will have 16. This is the second row. Then we bring the first one. Then we have 4, -2. We have 3, and then we have -2. And then we maintain the third row, -5, -2, and then we have 4. So this is what we call the switching of rows. After doing this, now we need to work on the second row in order to reduce this 4 to be equal to 0. Of course, we can use -2 row 1. Since we have 2 after switching, this will be -2 times 2, which will give us -4 plus 4 will give us 0. Our target is to reduce this to 0, so let's do that. Having reduced this 4 to 0, we also need to work on this third row, and our target is also to reduce 8. We have 8 here, and we need to reduce it to 0. Just like the way we reduce this 4 to 0. And to do this, we might need to do -4 row 1 plus row 3. -4 row 1 plus row 3. That will be -4 times 4. -4 times 2 here will give us -8 plus 8 will be 0. And here we will simply get -13, -22, and then we have -60. The next target here, so trying to make this -13 also to be 0 it will be a bit difficult. So what we will need to do here is to rewrite this equation. Let's try to reduce this -13 to something less or smaller, maybe -1. And to reduce this to -1, we can do -2 row 2 plus row 3. That will be -2 multiplied by -6 plus row 3, which is plus -13, and that will give us -1. If we do the same in -22, we have -8, and then we are also going to reduce this -60 to +8, and that will help us now to work on reducing this -13 to 0, 4 to 0, 5 to 0, and we also work on reducing this 2 to 1, because all the diagonal elements in this matrices must be 1, and this is why Gauss Jordan elimination method is a bit improved than that of Gauss elimination. Let's do that. So now, if we are done trying to reduce this -13 to a lesser number, this is what we get. After this, we will try now to interchange again. We need to interchange equation 3 and equation 2. That is taking this equation 3 to the top, and then bringing the second equation also down. So let's do that. This will be 2. We have 2, 5. So having interchange equation 3 and equation 2, the purpose of doing this interchange or switching is to get a better organized matrix that will help us work on the other columns that is remaining. So we now need to make this -6 0, and to do this we simply need to do -6 row 2 will work, plus row 3. This will help us to multiply -6 times 0 will be 0, plus 0 will be 0, -6 times -1 will be +6, minus 6 will be 0. So we want to make this -6 0. So let's see what we have. Our next target after this would be to reduce also this 41 to be 1, because we know for Gauss Jordan elimination all the diagonal elements must be equal to 1. So to do this, let's take row 3 divide by 41, because we know we have 41 here. So it will be 41 divided by 41. That will certainly give us 1 in row 3. Let's do that. Our next target will be to reduce -8 to 0. To do that, we can use 8 row 3. Let's say 8 row 3 plus row 2 plus row 2. This will be certainly 0, because 8 row 3 is 8 times 1 will be positive 8 minus 8 will be 0. So let's have that down. This is why we say that Gauss Jordan elimination is more tricky. You have a lot of operations to work on. The next thing we need to do here is to also reduce 5 to 0. We are going to make this 2 to be 1, and we are going to make this 2 as well to be 0. So let's bring this matrix down here and try to work on it. So to work on this row 1, we are going to do -5 row 3 plus row 1 plus row 1. Our target is to reduce this 5 to be 0, and if we do this will be -5. Row 3 is -5 times 1 will be -5 plus 5 will be 0. So that will work. Don't forget that all the diagonal elements must also be equal to 1, but not -1. So let's work on row 2, and our target is to reduce this to make this -1 to be 1 instead of negative. So let's do row 2 divided by -1. That will be -1 divided by -1. That will give us +1. So here we will have 0, 1, 0, and also this 8 becomes +8. And then that will bring us also, let's maintain the last one. This is 0, 0, 1, and then here we have 0, 0, 1, and then we have -2. So now let's work on row 1 in order to we work on row 1 in order to make this 2 0. Working on row 1, we are going to use -2 row 2 plus row 1. That will help us eliminate this 2. Here we are going to now have 2 0, 0. This 26 become 10. Here we are going to have our 0, 1, 0. We have 0, 0, 1, and here we are going to have 8, and this is -2 like we have here. The next thing is finally to make this 2 to be 1, and to do that we simply need to do row 1 divided by 2. Row 1 divided by 2 for our new row 1. Our new row 1. This will be 1. Here will be 0. This is also 0. Here becomes 5. Here we are going to have 0, 1, 0. This becomes 8. Here we are going to have 0, 0, 1, and this is -2. So this is what we have now as our new matrix. Therefore, according to Gauss Jordan, it helps us to solve the values of x, y, and z. You don't need to write it again as a system of equation. You can see here, having find this unit matrix, this gives us the values of x, y, and z. So hence, our value for x in this matrix, our value for x is already given as 5. Our value for y is 8, and our value for z is -2. And this is why solving Gauss Jordan elimination is more tricky, but it helps us to find